All right, Algebra 1. Y'all are my third recording, but let's do this. All right. When you're tired, don't give up. Middle of the summer, it's the middle of our summer session. But we're going to talk about polynomials, and then we're going to talk about some 8th grade math, some Pythagorean theorem. So this week is polynomials and Pythagorean theorem. Okay. Pick the expression that matches the description, a monomial of the second degree with a leading coefficient of 3. So some new vocab for you. We have, let's just do some work. And I'm not doing the success criteria this time. We can do that during the week. But I don't really know how much everyone is connecting and doing what I'm asking. And we had a pretty rough Thursday. So I'm going to contact your parents and we'll see if it gets any better. But I only know that I can do what I can do. So let's talk about monomial, binomial, trinomial, and then polynomial. All right. Maybe I should probably type this, huh? All right. Go faster too. No problem. So, monomial, binomial, trinomial, and polynomial. So what is a monomial? It is, it has one term. So what do you think a binomial is? It has 2 terms. And we talked about what terms are. Trinomial has 3 terms. And a polynomial has 4 or more. Okay, so that's what that is. Degree is the highest exponent in the polynomial. Easy, but you wouldn't know that unless you knew that, right? Can't guess what the degree is the way you could probably guess what a binomial is. And leading coefficient. So you should know what the word coefficient, which I cannot spell. Oh, it's right there. Oh, come on. All right. Coefficient. I get it. I got it. The leading coefficient is the, oh gosh, coefficient of the term that has the degree exponent. All right. A little bit of a rough start here, but let's try to pick it up. So we want a monomial, 1 term, second degree, exponent of 2, and leading coefficient of 3. There it is right there. Why is this not it? Because B, although it has everything, but it's a binomial. And what about this one? This has a leading coefficient of -1 because the term with the degree is -n squared. So it does have a degree of 2, but also it's a binomial. And this one has a leading coefficient of 2. So, all right, a third degree. So this is out because that has this is degree 8. Binomial, well, this is out, that's a trinomial. This is out, that's a trinomial. This has got to be this one. Constant term. Oh, okay, let's talk about the constant term. So what is a constant term? That is a term that does not have a variable. Constant term. Term without a variable. As we learned from Thursday's Ask an Expert, the math of making code, there's only variables and constants when you're talking about software. All right, so that is the vocabulary for polynomials. Then we're going to talk about multiplying them, adding, subtracting. We do as well when we multiply. So when we multiply using the area model, you know that area is length times width, right? A rectangle area is length times width. So we have 4 is our width, I guess. And then x squared plus 3x plus 2 is our length. So what we do is we just use the distributive property. So it would be 4x squared plus 12x, 4 times 3, and then 4 times 2, 8. And I like to write it on the inside. 4x squared would go there, 12x would go there, 8. That's the answer. Hopefully that's not too bad. But sometimes we don't have the rectangle written. Or I like to write a little rectangle because I think it's helpful when I teach, and it's even helpful when I do it for myself. So x plus 3 goes along the side. X minus 5, we're going to put those numbers. So we put each term in its own space. So don't put the minus in the middle, connect it to the -5. And then I could write the plus sign, but you don't need to write the plus sign. If it was a minus, I would write a -3 there. But it's a positive, so I'm not going to write a minus. Then we fill in the rectangle by multiplying. X times x is x squared, because 1 plus 1 is 2. X times -5 is -5x. Right here, we're going to multiply 3 times x, which is 3x. In the last box, 3 times -5 is -15. So that's how we fill in the box, and then we add the like terms. What are the like terms? They are right here, 3x and -5x. Those add to -2x. So our final answer is x squared, this box, minus 2x, this term, and then the -15. So that's our final answer. It's a trinomial with let's use our first, it's a degree 2 trinomial with a leading coefficient of 1 and a constant term of -15. All right, so use your vocabulary and then you won't lose your vocabulary. Now let's talk about some 8th grade math that never stops being important, I promise you. That is the Pythagorean theorem. So in a right triangle, not just always, but in a right triangle, if we label the sides A, B, and C, where C is always across from the right angle, then A squared plus B squared equals C squared. Now I can substitute 5 squared plus 12 squared equals x squared. I'm just going to do my squaring, follow order of operations, and then inverse operations. So 5 squared is 25. 12 squared is 144. Bring down the x squared. 25 plus 144 is 169. And now, please do not say divide both sides by 2. This says x squared. It does not say 2x. So we're not going to divide both sides by 2. We're going to square root. I'm going to write that out because I don't know if you know that is a square root sign, but now you do. Square root both sides. Don't say square both sides. Don't say divide by 2, say square root. And so the square root of 169 is 13. I happen to know that. So that's the answer. All right. This is not that much harder. We're still just going to use the Pythagorean theorem in this next assignment. But you should see that even though we have an isosceles triangle here, we have this dotted line splitting it into two right triangles. Not just two right triangles, but two congruent, same equal right triangles. So let's just forget about one of them for a moment. And we'll label this A, B, and C. And so we know A squared plus B squared equals C squared. And now we know A is 8. B is, well, I don't know what B is yet, but I know C is 10. Okay, so now let's do our squaring. 100. And so this time, since our variable was an A or a B, we have to subtract. You can always use that. If the variable is C, you add. But if the variable is A or B, you end up subtracting the two numbers. So that would be 36. All right, so then we square root both sides and we get 6. So B is 6. But as we have said, if two of the same triangle, so that means if I now take this back into consideration, then the side would also be 6. And 6 plus 6 is 12. So x, the whole side length, going to be both 6's put together, or 12. All right, so with some practice, I'm sure you'll have success with that one. And the last one is just playing around a little bit with the Pythagorean theorem. So a squared plus b squared equals c squared in a right triangle, but not in a not in a acute or an obtuse triangle. So take the two shorter sides and make them a and b, longer side c. So they're all in order here. And then just square a and b and see if they equal c squared. And then if they do, then it's a right triangle. If they don't, then it's not a right triangle. 5 squared plus 7 squared. So a squared and b squared get added together, and c squared just has to be squared by itself. Now I do want to take this opportunity to show you that the square root of 74 squared is 74. You can use the calculator. Find that out. It's 25 plus 49. Oh, check it out. 25, 49. That also equals 74. So this is a right triangle. 36 and 64. Oh, that's 100. So check it out. A squared plus b squared equals c squared. That's a right triangle. I have my doubts about this one now. So 25 plus, see, so 25 plus 64 is 100. Wait, 89 is not 100. I knew it wasn't 100. It's 89. And 9 squared is 81. So not equal. Not the answer. Not a right triangle. All right, guys. So try each assignment, post in the organizer, and I will see you on Tuesday with no blue start buttons, and post in the organizer. Bye.